So for this next part of the class, I'm actually going to be, again, completely swiping Kyle's presentation. And the reason for this is he actually did a very good job. And again, all the links are included in here in the class notes. So, review some of those links that actually go into more depth than the class. If, maybe we'll go into some details over here that, and then he explains it a little bit different. So I always like to learn things from many different perspectives. I think that that helps. And especially when you're learning something new that at the beginning, it just seems a little bit overwhelming. It's good to simplify it and then see how different people explain it so you can get different insights from different teachers. So anyways, just wanted to give you that aside. So let's, before we begin, let's talk about functions, okay? And then the difference between functions and procedures. And I think Kyle made a really interesting observation when he was teaching this. So let's look at these two functions. And again, this is, hopefully you guys all understand JavaScript, because we won't be covering JavaScript in this course specifically, but we do cover that in other courses. So let's look at the add numbers function. So the add numbers function, if we were to say, what's the difference between a pure function, okay, and that's a term that you hear a lot in functional programming, a pure function and an impure function, okay? So a pure function, why is this not a pure function, the first one? So there's a difference between procedures, okay, and then functions which actually computate something, right? So a procedure is you can almost think about it like a set of instructions that you're giving, the computer, or a set of instructions that you're giving to some process in your computer. And again, because of functional programming, we can parallelize these things and then split them. But the main idea is in functions, you want to create functions that actually describe, okay, what they're doing. That's the first concept that we want to understand, okay? Now, if we look at this add numbers function, we can see that it gets all its parameters, okay, from the function signature. So, and then everything that is using within the function, so to calculate, to do its work, comes in within the signature. So if it's not in the signature set as a default, it's not using anything outside of its function scope, okay? So over here, we have a function that calculates some total, so x, y, z, and w, and then we get a total number. But then what do we do with it, okay? We console log it out to the, we console log that value out to the console. Okay, now what's the issue with this? Well, in order for something to be a function, and this will be the first definition that you want to take note of, it has to return something, right? So if it doesn't return a value, okay, and undefined, by the way, even if it returns undefined, that is a return. But every function needs to have a return statement, okay? Otherwise, it's not a function, okay? Now, another thing, and we'll be going into this a little bit more in detail, what we call this over here, so the fact that the function is doing something outside of a scope. So if you can see over here, everything within the function, so the x, the y, the z, the w, okay, we actually got from whoever called the function. So once we made a function, like a call to this add numbers function. All right, so let's go jump over to the exercises. And then I have a work in progress folder over here that we're just going to run this function. So add numbers. As we can see, it's a very simple function, okay? But why is it not a pure function? As we said before, the first thing we want to make sure that every function has is a return statement. But besides that, okay, besides that it does not have a return statement, there's something else wrong with this function, and this is part of the reason why functional programmers are so adamant about dividing their applications into very discrete parts or sections that they can reason about. Okay, now simply because we're working within the JavaScript environment, okay, or the browser, we actually have access to this other function called console, right? But console didn't come in through through the function signature, right? So we never console at this point. We actually have no idea where this comes from, right? It just happens to know that we happen to know that we are in the JavaScript framework, right? And we're using JavaScript language within a Node application or the browser, and both of those environments actually do have this function called console as a global scope, right? But if you were to move this this library and you wanted to adapt it to something else, another language or something completely different, and let's say it wasn't the console function, but it was some other function that you got from a third-party API, you can see the issue that now this add numbers function, okay, is tied to this other function that we didn't, wasn't applied as one of the arguments. It's not in the parameters of the function, and we're kind of just getting this out of nowhere. Like, where does this console come from, right? So another thing to make something a pure function, and it's not just the fact that it's a pure function, right? We want to understand, why do we want it to be pure? One of the reasons why we want it to be pure is that then it could be interchanged, right? So if we were to do, for example, if we were to create a new function, okay, and let's call it output, okay, function, let's call it output, okay, and this function output takes in an environment console, right? An environment console. And then we're going to do environment console. And then we're going to call that, let's say that's a function, environment console function. And we're going to call it with the second argument, some string. Let's just say that. And then let's call it string. And then let's call this function. And what we're going to pass to this function is the console. And then we're going to run it. I have to pass the full function. Okay, sorry about that. And then we have to pass the second argument. So let's pass in a second argument as hello world. Perfect. So now we can see that because we created this new function called output, okay, output takes two arguments. And the first argument is, depending on the environment you're in, we're not going to say, we're not going to infer for the user that we know what environment they're in, right? So now anybody, right, we can go ahead and actually export this output function. We can go ahead and export this output function as an API ourselves, and pretty much anybody can use this this utility function, which is, again, it comes pre-built in JavaScript, but imagine it didn't, right? So now the actual caller of the function has to provide every single thing that we're going to be using in the function, versus what we were doing over here, right? So because we don't know that, if all we did over here now was if we were to say, provide for us as the first argument that in the function, okay, so let's call add numbers again, add numbers, and then the first argument we're going to pass to it, and actually the only argument, since the other ones are default, is that. And then what we're going to do is we're going to say we're going to call that function, and then we're going to call it with the total, and then we're going to actually log it. Let's take this export out for now. Let's just log that, and now we get a 0. But this is a completely different function in the sense that we actually did include every single variable that we're going to be using in the function, right? We didn't assume that that we knew where this how this function was going to work. And now within the scope, whoever's reading this code later on, and again, as we spoke about in the beginning, a big part of functional programming, it's all about the maintainability. So understanding these core concepts is going to become crucial to when we're building our apps later. The first concepts that we want to make sure, and it's still, we're still not returning anything. So let's just do a simple return. But now the add function, the add numbers function that we built, kind of has everything sent in, okay, within the function signature. And again, maybe we can say within the function signature that we have this as the default value. That also would have been fine, right? Because we can see that we kind of get the same. Now, even if we don't send it in, the author of the code set a default, okay? And then we get to use that function here with the total and then return. So what are we returning? We can return the total, okay? That's fine. And then that would actually make it a pure function. So now that we're using, okay, so what are the concepts that we have learned about function and function purity? The first concept is every function must have a return statement, okay? The second concept is the function, okay? Whenever you see a function accessing some, okay, it could be a variable, it could be anything else outside of its scope, okay? And the scope is within the function statement, right? Within the body of the function. If we see that the function is actually making a call to anything that is not actually within the function call, then that should raise a red flag. And the reason being is not that we can't access things outside. And we will see ways that we do that in another video. But the main thing that we want to understand is if we wanted to give this function, okay, we wanted to export it and we wanted to create an API that everybody can use, right? If we would have tied, right, this console log that we're using, and then in the environment that they're executing this function, that is not there, then automatically our function or our API gets deprecated, right? Nobody can use it. So all that work that we did becomes null, right? It becomes nullified. It's unuseful. So part of the reasons why we want to use everything, okay, within the function, it's not that we can't access things, right? That's not the way we should think about this. The reason being is if we want somebody else to use our functions, right? If we're working in a team and we need our team to, maybe we have a front-end team and a back-end team, and that those teams need to communicate, then it becomes very important that the functions we create, okay, are self-contained. Okay, self-contained is a good way of thinking about this. Now, because this function is self-contained, we have included everything that we're going to be using within the function, and we have a return statement. So it actually does not. So this function can actually be called, and let's say we want to get total over here, and now we will make this total is different than this total because we're outside of the scope. Now, if we console log over here, outside total. Okay, we should see two console logs, but this is the inside total. Okay, that's the total that we got from using the console log because we wanted to console log something out. But then we also see that it got a return statement. Okay, now if we remove the return statement, okay, and all we do is not have this again, what do we have? An undefined. Okay, and we could return undefined. That would be explicit. Okay, and again, we will have the same thing. Sometimes it's completely fine to return undefined if that's what you want to do. But, the important thing about, why we want to go through the trouble of learning functional programming and all this is about these concepts. And these concepts, one of the main things that it allows you, okay, is that they're provable. Okay, your programs, now instead of having a 100-line program here that uses variables outside of itself, as accessing things that it shouldn't be the way, it's not that we can't use a console log, as you saw. All we had to do is include it in the function signature or include it as one of the variables that we include with the function. So there's ways that we do it, okay? And that's the difference that we want to start thinking about, okay? We want to learn how to include this and not start accessing things because, again, one of the hardest things to debug, especially in programming, and when a program is small, it's not such a big issue. But as programs get bigger, it does become a bigger and bigger issue. One of the biggest things to debug is state change, right? So if this function is accessing something outside of itself, okay, and let's say there's two people using this function, right? So there's two clients on the UI that needed access to this function and was using this function, and we're calling things, okay, we're changing variables outside of ourselves, then we might change something that we didn't intend to, that somebody else was using simply because we're accessing things outside of ourselves. So now, although this function does return undefined, everybody, okay, that uses this function can be sure that, we are not going to change something within the program, right? And if you have, again, a back-end team and a front-end team, or your team is growing, then that's when these things become important. And even for yourself as for your future self, okay, as you're debugging your own programs, it's so easy now to go in and actually test this function out. Does it actually return what we expect it to return, right? So we can say that, hey, we expect this total since we know all the arguments going in, for the same argument, and this is another concept that we're going to go over, but for the same input, given the same input, do we get the same output? And this function absolutely gives us the same output. First and foremost, we're returning undefined, right? But even if we were returning the total, let's say, we can see that given the same input, right? So as long as we provide, and even if we don't provide anything, okay, the function signature kind of takes care of it for us. But, within that, we can say, hey, if I console log total equals 4, okay, and I wanted to see if that's actually true. Let's see here. So we have add numbers, and let's see. So we have that being false, but since we didn't include anything, so we know that once we call it over here, we did not include anything, right? So we're like, okay, not including anything, can we make any assumptions about the output of this function? And we can, right? We can say, if you don't pass anything to this function, okay, we can write very simple tests. We can say, hey, we know that, you're going to get a 0 out, and we can prove it, right? So the provability of the function becomes important, right? So you can start testing, your APIs in self-contained areas, and you can be sure that when somebody else uses it, you can give them a function that has a predictable way of behaving. And that's part of the things that we want to understand as functional programmers. Okay, we want our functions to behave in a predictable way, especially if we're going to have code that's growing and we're going to be importing modules or APIs from the outside, and we're going to be using these modules. We want a certain behavior that we can guarantee to the user of the function, and we can say, hey, you know what, this is how this function is going to behave. If you're provided a console log and then 3 variables, what it will do for you is it will add them up. Okay, it will give you a total and it will return that total. Okay, and then it'll also console log or whatever log, however you want to express this, because although we have this set as the default variable, you can pass in anything else, right? So let's say you were, using a Raspberry Pi, or you're using something else, and display is not in a console log, but maybe you have a standard out, right? So standard out is another process that does a very similar thing to console log in a different environment. So maybe you are you want a standard out console, but you don't have access to console log because you're not in a JavaScript environment. Then this function could still work. Okay, this function will still actually perform everything it needs to because it's being passed. Okay, right here, or the user itself of the function can specify themselves. Okay, because we've given them that ability and we haven't constrained them to saying, hey, you know what, it's going to be console log or you're screwed, right? We didn't access something that was outside of our purview, right? Outside of our scope of the function. We include it as a default, or the user can include it themselves. We've included defaults for all of our variables. We have a return statement, okay? And we have a way for our function to behave predictably, okay? And those are the main concepts that, those are some of the main concepts of function purity, all right? So let's keep moving through this. I hope that was, again, I know that was a bit of a lot of detail, but that's why, these concepts are, the first things we're going to go over in the course is the theory behind what functional programming is, so that you can understand that, hey, you know what, this is not as hard as other people, make it out to be. Okay, it's just understanding simple things and what these simple things allow for us, right? So if we write our programs with these things in mind, what does that buy us, right? Why do we want to write our programs this way instead of the inheritance method? So again, now we have a way of kind of abstracting our functions, right? So writing them in self-contained. Okay, so we have functions that ideally just do one thing, right? So this function called add numbers, besides the fact that it's pretty descriptive, right? So besides the fact that it's gonna, it kind of, the name says it, and again that you can make your functions descriptive or not descriptive as you want. We're also passing in other variables, right? In this sense, now we know why this is not pure. So the first thing we know is it doesn't return anything. So as soon as you see a function that does not return something, you're like, okay, there's a red flag, right? That's not a pure function. That function should at least just return undefined, okay? So that we have a predictable behavior. Also, we're accessing this thing called console outside of the function. Like, where does that come from? We have no clue. Okay, at this point, we don't know. So the function doesn't specify it. So the user of the function, this function's, imagine this is making a database right, and it's producing all this side effect that you did not intend to, or as a caller, it's writing to a file, or it's reading from a file from the user. You honestly can't make any many assumptions about the function. So again, this could be code that someone puts in the function of the API you're using, or whatever. If we have a pure function, we have a way to, we have a way to prove that what the function does, okay, is self-contained within the function, and we have a way to write tests against this, okay? So the function behaves in a predictable way, given the same inputs. Okay, and if we go back to the function, let's as the first argument, let's include console log, and then let's provide it a second argument called for. So what do we expect our function to equal now? Okay, let's say, do we expect it to equal 4? Okay, I mean, that's what I expect it to equal, and knowing what you know now, you should as well, and you should be, you should have a high degree of confidence, okay, that this function is gonna produce the number 4, and it does, right? So we see in the console log over here, it produces 4, and in our test total, does the function equal 4? Once we passing these two arguments, can we can we make that statement? Can we make the statement that this function will output the number 4? And we can, right? We can prove it. We know why it does it, and we know that it returns 4. We know that, providing the arguments, what it does. And again, we can export this as an API. And now we have a little function utility that adds numbers for us. And as long as you provided the XYZ, it adds them up for you and it returns it, right? And in the return, and then now anybody can use this, whether in the client, in a completely different environment, and everything that we just said about this function holds true, right? So now we have, again, if we're thinking in components and we're thinking in these smaller bits that will at the end, we want to think like Lego pieces, right? So all these small Lego pieces, what we're going to do eventually is we're going to compose them for them to create our application. And just like a small Lego brick, once you start putting them together, they all kind of fit together. Okay, and then you can make almost any shape you want, right? You can make almost anything that you want to make. It's the same thing with functional programming, okay? Once you start building your Lego pieces, then you can decide, or anybody else that's using your API can decide how they want to put it together. And, and they're not tied to a framework. So if today, a very popular framework is React, and tomorrow, your team switches to like Ruby on Rails, a completely different language, you can still bring this in, and on the server maybe keep a Node, and on the client you keep it a Rails application, but you can still use most of the code that you have written, and you can switch between frameworks, language, or anything pretty much you want, and then your code still works across all these environments, and that is a huge win, right? Especially if you want to hire people, or if you want to come into any team, once you understand functional concepts, then all you really have to learn is the syntax, right? The syntax of the language. So anyways, so that's the first thing about functional purity that we want to go over. Now let's go over some other terms that a function must have in order to preserve its purity. Okay, so now we're going to look at a different function. And again, as we can see here, this function is called tuple, okay? Tuple, all it does is it returns x plus y. It returns just two numbers, right? That we can store in a tuple. So a tuple is just that. It's a collection of two values. Okay. And again, we're using some destructuring. So hopefully you have in JavaScript. This is the spread operator. So kind of what it does is it kind of introduces each value individually. So over here we want to pass a collection, but the function itself, the parameters it takes in is one at a time. We're passing it a collection, so we use the spread operator so that it applies them for us individually, one at a time. And then the return value is we're using the x that was passed in and the y, and then we're using some literals that every single language will have, right? So we're not accessing anything outside of ourselves. Everything that we need for this function to work is passed in, and again, it has a return statement. So this actually makes it a pure function, and it really is that simple, right? That's all you need to make something a pure function, and to make it reproducible, right? And again, if we go back to our calculus or algebra class, again, this should remind you of exactly of an f of x problem. So again, passing an x to a function, this little machine will produce the same result. So as long as you pass it the same x, you should expect the same parabola or the same result back. So you pass a 5, you will get the same answer every time you pass a 5. Okay, you won't get sometimes this answer and sometimes this other answer. Okay, you will get the same answer every single time. Passing in the same inputs, you will get the same outputs. Okay, so that's another thing that we want to remember. So the way Kyle explains this is a function, the semantic relation between input and computed output. Okay, and all that means is really, given the same inputs, do we get the same output, right? So in a car, if we are using that as an example, every time you step on the accelerator, it will move forward, right? And again, unless you have it on reverse. So as long as it's on the, if you press the accelerator and it's on drive, then the car will move forward, okay? It's not that sometimes when you get in the car and you put it on drive and you press the accelerator, it's going to brake sometimes and it's going to accelerate sometimes. Imagine if that was the way we drove, right? Hey, you know what? Sometimes this is going to brake, sometimes this is going to drive forward, or sometimes it's just going to stop. Like imagine if you couldn't make any any assumptions about the way that the car moved, right? Or if you move the steering wheel to the left, the car is going to rotate to the left. If you move it to the right, it'll rotate to the right. So that's, and you can do it 1,000 times, and 1,000 times it will do the same thing, right? So that's kind of the same things that we want to get at with our functions, give them the same input, right? So if we provided the same behavior, we should expect the same behavior out. And again, it should be provable, right? So, and it should not matter who's behind the wheel of the car. Every time you rotate to the right, the steering wheel, it will go to the right. Every car, right? Every car does the same thing. It doesn't matter. Okay, and again, if you're not in a car, if you're in an airplane, it's gonna move, it's gonna work a little bit different. Or if you are in a bicycle, the way they move forward, they all move forward, but the way they move forward, it's a little different, right? But what you do expect is that if you get in a car, okay, and again, as long as you know how to drive a car, and you know what the steering wheel does, and if you move to the right, every time it's gonna again make the car go to the right. And again, with our functions, that's kind of the behavior that we're looking for from a functional programming standpoint. Now let's go into side effects. And again, we already touched upon this, but I want to emphasize the importance of why it is that we go out of our way to not produce side effects. So what is side effects? Side effects are any time. So remember at the beginning of the class, we talked about what it is that we're doing with the data. We're actually transporting data, okay? Changing the way the data looks, okay? So changing the shape of the data, so that return value. Okay, that's essentially what we're talking about there, right? What does the data look when it comes in, and what does it look when it comes out? Okay, that's the mutation part, and then the display part of the data. Okay, at this point, when we talk about side effects, we're talking about the mutation part. Okay, so it's not that we don't want any mutation, right? If all of our programs need to have mutation, okay, we need to be able to change the way an application behaves, right? So let's say we turn on a computer, right? When the computer is turned on and when the computer is turned off, it behaves very different. But every time we press that button, it's either going to do one or two things. Turn it on if it's off, and turn it off if it's on. Okay? And it doesn't do anything else, right? And that's the same thing with side effects, okay? The side effects, we want to incorporate them. Whatever side effects that we want to do, we want to make sure that we do it within the scope of our functions, okay? We don't want to be changing. So over here, shipping rate. Again, it's the function that calculates your shipping rate. And we're accessing, we're not declaring a variable over here, right? You don't see a var declaration. What you see is the variables has already been declared somewhere, and it hasn't been passed into the function. So what we're saying over here is, hey, we're going to be accessing this variable that's outside of the scope of the function. We're going to be accessing this other variable called size that's also outside of the scope of the function. We're going to be accessing this other variable called weight that's also outside of the scope of the function, and speed, which is also outside the scope of the function. And what we're going to do is we're going to calculate, we're going to use all those variables that we have no idea where they come from. So imagine if someone, okay, is using your API and it's like, hey, you know what, this function doesn't take anything in, but somehow we expect it to output, what do you expect to output? Like nothing has been passed into the function, so we can't make any assumptions. Nobody else, okay, can use this function except the author of the function within the context that it was written in, right? So this function is not portable, right? We can't export it into anything. We can't import it into anything. So it can only be used within the context of, again, a very small program that has all the variables right within the scope, right? Accessible within right outside of the function. If we pass this function into another function as a callback or anything, then automatically we're going to get an error because neither rate nor size nor weight nor speed, we don't know where we're getting this from. And again, maybe the other function has all this available, but it's not something that we can count on, right? So at least we should set the defaults. That way it doesn't error out. And again, we should return. We see that this doesn't have a return statement, and again, we're accessing all these variables outside and changing them. So the first time we call shipping rate, okay, with these variables, size being 12, weight being 4, and speed being 5, we call it. We're gonna get the number 57 out, okay. The second time, okay, and again, we're gonna change outside of the function the size and the speed to different variables, and then we're gonna call it again, and now we get the number 42 out, okay. We have no idea why. Okay, why did the first time did it give me a 57, and the second time I called it when again maybe we're expecting the same 57. Now we get 42. Now, again, in a small program, it doesn't matter much. But when your program is dealing with client, server, and multiple files, so the data could be in multiple states and multiple files and multiple people accessing the same data. And one time you get 57, and then another time you get 42. Again, good luck trying to debug that, right? And if you ever dealt with this type of issue, it could take hours just to debug a simple thing, because one time it gave you a 57 and then the other time it gave you a 42, and you can't even reproduce it, right? So you can't even write tests for it. So there's no way to test it. There's no way to say, hey, this is what the behavior is. And every time it's giving you different values. So again, this function, as it stands, is almost useless. Okay, nobody else can use it. And again, completely arbitrary behavior, and we don't even know why. Now, if we again pass in the variables like we're doing here, and we return the calculation, okay, we don't access a variable outside. So notice the difference over here. We return just the output, just what the calculation is, given our variables, the arguments that were sent into the function. Now, whenever we call rate, okay, and we pass it the number 12, 4, and 5, we will always get a 57. And whenever we call the same function with 8, 4, and 6, we will always get, 42. And now we actually know what's actually affecting our function, right? So now anybody can use this function. So now this function is reproducible, testable, and portable, right? And it is, and again, it's time and time again, given the same inputs, we should expect the same output. So again, avoid side effects with function calls whenever possible, right? So that's one of the things that will make your functions not pure. So, but now let's talk to the other side of this coin, right? Because again, like we said, we're gonna need side effects, and you're like, well, how do we write programs that don't have any side effects at all? That's impossible, right? You're gonna need to an IO. You're gonna need to read a file, write to a file. You're gonna need to output something to a display. You're gonna need to maybe write something to a database. You're gonna need to fetch something from a database. You're gonna need to change the DOM, the way something looks. You're gonna need, even get the time, right? The time. Every time you call the time, that's changing. So that's already a side effect. That's not, behavior that can be standardized. You call it at a different time every time, and you will get a different time. Like go figure. If you want to generate random numbers, again, that's a side effect. And you can make the case that even the fact that you turn on your computer and it's using CPU heat or electricity in your house or anything that's observable, that's a side effect, right? So it's almost impossible to write complete programs that don't have any side effects, right? But what you want to do, right? So that's what we want to get at, right? And when you hear functional programmers speak to writing functions without side effects, they're not talking about writing whole programs, right? What they try to do is they try to separate, or they try to, separate their function logic, their program logic, from the parts that have side effects from the parts that don't have side effects. And this way, the functions can be composed. And once they're composed, and once they have it in the shape they want, right? Once we have our Legos how we want them, then we go to the other side of our program where it's going to be full of side effects. And then that way, if we do have any bugs, we don't have to look in 80 places. We have a place in the program where everything is very testable, right? We have provable functions that are portable, they're small, and everything, given the same input, we get some output, so very predictable behavior. So we know our bugs aren't going to be there, right? So our bugs now are just contained to one part of the program. Okay, so again, this gives us a lot of flexibility when writing programs, and not just that, when dealing with teams, because we can say, hey, it's not that we won't have side effects, right? We're writing programs over here, so we need to affect something, right? Otherwise, what are we even doing? So I mean, again, even if you're just making a rotator that shows different wallpapers or something, right? Every time you get a new wallpaper, you gotta get it from somewhere. So there's a side effect. But what you want to do is you want to, separate maybe the rotation part that again from the fetching of the wallpapers, and then what you do is you compose those two things together to create your application. But there's a part of your app that all it does is rotate, and you can essentially pass anything to it, And then there's the other part of your app that grabs wallpapers or grabs whatever and then passes it into the part that rotates it. But the part that rotates it, it's very predictable. okay, versus the part that grabs the wallpapers. Because today you might be grabbing wallpapers from one from one location, and tomorrow you might want to change your location to change what the wallpaper is, right? So that's changing all the time. But the part that rotates the wallpapers and how that behaves, that doesn't change, right? So again, it's not that we want to write programs that have absolutely no side effect, okay? Is that we want to deal with functions, okay? We want to be able to separate our code base into parts without side effects and then parts that have side effects. And then that's a huge win for understanding, predictability, and reusability of our programs in the future. Okay, so again, let's go over a few more examples of pure functions and not pure functions. I think in the beginning it's good to get a lot of repetition just to understand and really drive this home. Okay, so add to the first function that Kyle's showing over here says add to, and then we provide an x and a y, and then we're returning the x and the y. And that's simple, right? So given the same inputs, we're going to get the same outputs, right? Given a 5 and a 3, we're always going to get 8. And that's not going to change. Now we have add another. So this function adds two numbers together, and then this other function takes the same inputs, and it's calling, okay? It calls this function add to, which is a pure function, okay? But then we add plus z, and again, we have a return value. So everything, we have a return statement. So everything here looks good, except for the part over here, right? That now we have the z coming out of nowhere. Like, where did the z come from? Again, that automatically invalidates it, and it's not a pure function because we're accessing things outside of our scope, right? And as soon as we're accessing things outside of our scope, we should move that behavior into a separate function. And that's totally fine if we want to do that. But that's right. This is the part of our code that's pure, and this is the part of our code that's impure. At least we can reason about that, right? So, and again, maybe this is exactly what we want, and we will see in a little bit maybe why. But now we can at least reason about, right, what's pure and what's impure. Okay, so this add to function is completely pure. So this add to, we know what's going to do. Now, we don't know what the z is going to do, but the add to, you see how another function can use it, and it's very reusable. So this piece right here, that's what abides us, right? We can kind of import it, export it, use it within other functions, and know the behavior we're going to get. Now, when we add z, now z could be a number, c could be a string, and that's going to behave differently depending on the environment you're in, right? So again, we don't even know what z is, and that creates the impurity within our function. Now, let's say that we have this variable z over here. So now we have a little bit more of we're zooming out a little bit, right? And now we can see that in line 1, z is a number. And, if we call 20 plus 21, given the fact that z, like, let's say it doesn't get changed anywhere within our program, right, other than over here, then we can make an assumption that that this function, again, although it's not pure, we can prove it, right? We're going to get the same for the same 20 and 21. We're always going to get the number 42, right? So within what we can see of our program, right, from lines 1 through 11, does the value of z change? Does it get reassigned anywhere else? Not really, right? All we're doing is we're using it over here, but it doesn't get reassigned, okay? And because it doesn't get reassigned, then we can at least satisfy one of the criteria of our function, which is given the same inputs, we're going to get the same outputs. And in this case, we will, right? So in this case, given 20 and 21, and knowing that it doesn't get reassigned, we will get 42 out every single time. And we do have a return statement. But again, if somebody else is using this function and reassigns that value z, then automatically we can make no assumptions, and the function goes into the impure. Now let's look at how we can turn that function into a pure function. We have a function. So what we've done is the add to function, we've wrapped it. Okay, we've wrapped it into another function. Okay, and then what we're doing is we're passing the initial value z1 to that function, and then that function takes in other two arguments, right? So that returns a function, and that function takes two arguments, right? And then what we do is we have close over. Okay, we're using the variable z. So this function, let's say we do add another. Okay, and let's write it out here for us to for us to get a better idea. Okay. So let's say that let's take the z out of here. Okay, but we still want to calculate z. Okay, so what we want to do is we want to say, hey, let's make this add another function, which takes a z, but what it does is it returns a function. It returns the add numbers function. Okay, add numbers, and then we're going to remove that the first console log. So we know that the add numbers function takes an x and a y, and then what we want to do is I'm going to move this over here so it's easier to understand what we're doing. We're going to return it. So we have the return statement, and then we're going to return. We're still going to. Yep. So we're returning. Okay. So we have two returns. So this function over here has a return, and then this function has a return. So every function must have a return. Okay. We're accessing the variable z, but the variable z actually gets called and accessed within the scope of our function, right? So if we go and say, let's call this one add2, okay? And let's pass to add2 the first argument. So the first argument takes a z. So let's call that the number 1, okay? And then let's say var, and actually it's add number, add another that we have to call here. And then this one's going to be called this variable. Let's call it add1. Okay. So add1. If we call add1 with now, you remember if add1 now is going to return, okay, a function, okay, that takes 2 arguments. Okay. So let's call it add2. Okay. So that it's easier to understand. So now when we add another, we're passing in the number 1. And then when we call add2, because it returns a function, so now this add2, okay, if we call it, let's just console log this out for a second, just so you, if we were to console log this out, what do you think we get? We get a function, right? So it returned a function. So this is still not our value. So this is now a function that we can call with 2 values, okay? So let's go ahead and provide the next 2 values, so 1 and 2. So we can see 1, 2, and 1. So now, and let's actually console log this function here. Now we can console log the actual result, okay? And then we get 4. So we have 1 plus 2 is 3, plus 1 is 4. But now, within the add another function, okay, we're accessing all the variables within the scope. So what have we done? We have wrapped, okay, what was initially an impure function, okay, we've passed it, okay, and again, we can do this in different ways in JavaScript. But now, if we console log, we still get number 4. So the first argument we're passing is the number 1 that returns a function. Then when we call it again, we can pass it 2 numbers, and the 2 numbers are 1 and 2, or whichever other 2 numbers you want. And now we can console log that out, and we can see that this has a behavior. So given the number 1, and the number 2, we're always going to get the number 4 out, and that's provable within our function. So that's one way that we can go ahead and make functions pure, right? We can start understanding that there's always ways to make impure functions into pure functions, and one of those ways is by wrapping it in another function, so that it's not accessing outside of itself any other variables. And that's one of the main bugs that you're going to come across when you're programming. So again, what can we say about purity of a function? When we say, whether this function is pure or not pure, really what we're talking about is the level of confidence that we have. Can we, given some inputs, how confident are we that we're going to get the same output? Okay, and that's what function purity is all about. How confident are we that given some inputs, we're going to get the same outputs out? Okay, and again, we want to focus on function calls, right? Not function definitions. So this is definition, okay? But not until we actually call it, okay, do we actually run the program and is actually any work being done. And this is another thing that we're going to get to, which is lazy functions versus eager functions. and again, in JavaScript, if you've ever dealt with promises, you know that promises, you have the .then, right? API that they've added to it. And until you call .then, you actually can't get the value out, right? So it's a very lazy function. So you can set it up and, you can pass it along. And only once it gets called does the value come out, not once it gets defined, right? So again, we want to think about this like little Lego pieces that we can pass around. And again, whether you buy different Lego sets, and you've been buying Lego since forever, and all the pieces work. Okay, now what you can build with those pieces, it's infinite. You can build infinite things with it, and your imagination is really the limit. But that's what we gain when we decouple our functions into smaller pieces that do one thing. Then we can start composing them, and then we can really compose big applications. So what we're really trying to understand here is, how do we go from the very basics to writing big applications with functions and in functional programming. As you can tell, it's not that complicated, right? But we do have to understand these basic concepts that allow us to do that.